Again, that's just notation. There is nothing new mathematics going on in there. This basically says stock value is present value of all expected dividends in the future. In fact, I should make a note of that. DT is expected dividends in year T. And it makes logical sense. What's the problem operationally? If we wanted to use this as a way to calculate a value for a stock, what is the first problem you're going to hit to make this operational? Theoretically, it's beautiful. No question about that. What's the first practical problem? It basically says find out the expected dividends from now until the end of time. Do you think that's possible? No. Okay. So there are infinitely many inputs. If you think of this as an algorithm, there are infinitely many inputs. So we're going to have to kind of do shortcuts. The second one is you need to forecast all the dividends. Even if I limit it to 100 years, trust me, present value of something after 100 years is minute. Is there any, let's think about Coke, the company. And you go to the CEO, CFO, and ask them, please give me your forecast of your dividends over the next 100 years. Do you know what will happen to you? They're going to put you into a room with some, soft walls. Even those guys have no idea. 5 years, they could probably do it. If you force them, they can give you something up to 10, but that's pretty much the end of it. Even if it did, even if such forecasts were available, you're subject to, bless you, the statistical version of this is one of my favorite laws, second law of thermodynamics. It sounds very fancy, and it is, except in quantum environments, this always applies. Anybody knows what the second law of thermodynamics is? Anybody actually took physics for the science class? I didn't think so. It basically says, as time moves on, the overall complexity of a system has to increase. The statistical version of that is, if you forecast longer and longer into the future, the uncertainty you have with those forecasts keeps increasing. Think of it like this. I can forecast what's going to happen to this next year. Good. Then 2 years from now, there are stuff that will happen in those 2 years that I don't know about yet. So that means it has to add to my uncertainty. So uncertainty associated with longer term forecasts of dividends are higher. Somebody raise their hand? Oh, no. Okay. So we kind of, to make it practical, we have to take some shortcuts. So we'll do some special cases. I'm going to actually call this case 0. Assume dividends will be exactly the same. $D1, whatever that number is, right? When you do that, sum of t equals 0 to infinity, D1 over 1 plus R to the T. D1 is the same, so it gets out of the summation sign. That is an infinite series, but thankfully, we know the mathematical consequence of that sum. This is a convergence series sum, which means if you add more and more term, the change in the sum is going to be even less and less. And if you worked out the limits, this is equal to 1 over R. That means on case 0, value of a stock is equal to the dividend that you know you're going to get every year divided by R. This is also sometimes known as the capitalization of dividends. In real estate finance, instead of D1, you use the rent, annual rent. Annual rent divided by the discount rate is called the capitalization of rent. That's the minimum value you should attach to a house. If it has a rental potential, at a minimum, it should get that. But assuming dividends are going to stay exactly at the same rate is a little bit unrealistic.